Well, hey there, how you doing? Welcome back to my YouTube channel. Thanks for being here today. Really glad to have you here. I want to talk to you today about the exciting subject of crop circles. You know, this is something I've been involved with since I went over to the UK in 1997 just to get some feedback on one of my RV sessions, which happened to be a crop circle target, the Windmill Hill Julia set. And I noticed going over there that people were reporting stories and experiences of having camera and battery failure in their devices when they went into the crop circles. And I started seeing this myself the following year. Started seeing my own devices starting to act weird. And, you know, the camera wouldn't focus properly. Batteries would stop working. The device would just go on the fritz. It'd have to be rebooted. You'd have to start it up. I've seen this many times. Even when I was filming with the National Geographic Channel in 2009, they told me that when they had been in one of the formations around Silbury Hill the previous year, that their camera had failed so badly. One of their expensive beta cams, you know, these cameras cost tens of thousands of dollars. They couldn't get it to work after being in a crop circle. They had to call back to headquarters in London to reboot the entire camcorder to get it to work again. So I've been wondering ever since, what is causing all of this weird electronic phenomena in crop circles? Now again, this is something I've personally seen with my crop circle tour guests and my own cameras year after year after year. So these aren't secondhand stories from my experience. I heard the stories from other people and I've seen it myself in my own devices. So what is going on? Your camera? And has it ever done that before?
No, I've taken 900 photos on it and it's just stopped.
And what do you think's causing that?
I got no idea, but when I get it, yeah, it's probably because I've catch a plane.
Okay, Dan, can you tell me about what happened with your compass here?
I have a digital compass, a Casio readout compass. Anyway, it's lost its calibration after I was on the crop circle. It came back and it's, I turn 90 degrees, I get a 180 degree reading. In other words, it shows north over here and south over here, which is be 90 degrees to each other. So something's happened to it.
Has it ever done that before?
No.
Thanks.
Okay.
Oh, about 50 yards from the crop circle, my camera was working perfectly, which, by the way, is a brand new, very expensive camera. And now, upon entering the crop circle, it lost its ability to focus, and now I think it won't even turn on.
Has it ever done this before?
Never, ever. I think it's shot. Wow.
Now, first of all, this doesn't happen in every single crop circle. It happens in a small percentage of crop circles. I would guess perhaps 5% of the crop circles. So that may mean that you may see it once in a summer if you're going into a whole bunch of crop circles, or maybe even not at all. But I've seen it enough to know that this isn't just a random sort of process. This isn't just people's cameras and batteries just failing, because if that were true, you'd see this happen all the time in your devices when you're just at the beach or on vacation somewhere. It doesn't seem to happen then, but it does seem to happen in crop circles. So what's going on? I have been really looking into this for about 2 decades, and fortunately, the science has caught up with our observations so we can start making sense of what these crop formations are doing. It was Colin Andrews who pointed out to me. He said, Simmy, it's very interesting because the wheat in the fields is standing up, the stalks of wheat, and they're not touching each other. And then we're on the ground, they're all kind of in a pattern, they're swirled around, they're touching each other. Maybe it's that the field as a whole is acting like an insulator, and the crop circle wheat itself, mostly wheat because most of these formations are in wheat, the crop circle wheat is kind of acting like a conductor. So I started thinking about that, and this is about a good 10 years ago that he kind of mentioned this to me. And what we have now are a lot of developments in science around materials that can act like metals and start conducting, and a whole new range of materials that we call topological insulators, which are actually compounds that don't conduct very well and mainly act like insulators in the bulk, but at the edge they have very high levels of electrical conductance, even approaching superconductivity. So topological insulators are actually things that are mostly insulators, and at the very edge they're superconductors. So think about it for a second, because wheat itself is kind of like an insulator. You're not going to get a lot of electrical conductance if you put little metal probes on wheat. But the very interesting thing about it is the properties of these topological insulators that scientists have found in the lab. Those properties also apply to crop circles, and let me explain how. What a topological insulator is a compound of two elements with very different topologies. Topology is actually not about the shape of something, it's about the fundamental properties. And if you put two compounds together that have these very different fundamental properties, the electrons seem to have a certain structure. At the edge of the compound, the electrons sort of don't have anywhere to go, and they end up forming a loop and create superconductivity. Superconductivity is different than the normal type of conductivity we have in metals, because in metals, the electrons are bouncing around. The metals themselves have very disorganized structures inside. They're not perfect crystals. So the electrons bounce around, and a lot of them get lost to heat and so forth. So it's very inefficient. And this is why all of our devices generate a lot of heat, right? And you have to recharge your batteries, replace them, because the electron conductance is very inefficient. But in superconductors, it's extremely efficient because the electrons flow in a kind of perfect way and there's no resistance. And so superconducting devices are thousands of times more efficient than regular devices that we have now. And you can get superconductivity at temperatures really close to absolute zero. But the holy grail for material scientists is to get superconductivity at room temperatures, where we could actually use it and have devices that would only need to be charged up, like if it was your cell phone or something, like once a year, right? Because the electron flow would be so efficient. So in these topological insulators, the properties of the electron structure are such that they allow superconductivity just in a very small area of the material right at the edge. And to explain topology, physicists often talk about the idea of it's a fundamental property that really doesn't change unless you were to completely destroy the thing. So for something like this, a tea mug, coffee mug, would have a topological number of 0 because there's a hole in it. And even if we changed the shape of this coffee mug to different shapes, it would still have a handle with a hole in it. It would still have a topological number of 0 versus an object that maybe doesn't have a hole in it and just is like this, and it's a solid surface, and this would have a number of 1. If you put objects with 0 and 1 next to each other at a molecular scale, they have very interesting properties. Now, if you look at the crop circle itself, you also get this kind of topology. It's kind of along Colin Andrews' idea, but not exactly the way he described it, but kind of related. He was kind of on the right track. He just said insulating areas outside the crop circle, conducting areas inside. And if you look at the crop circle itself, in the field, the stalks are all standing up. That's one sort of general property of the wheat. But then inside the crop circle, what do we have? Windings, spiraling shapes, and spiraling characteristics of the wheat itself. And those characteristics give the topology of the crop circle a very different set of characteristics versus the topology of the standing field. And if you put those two different sort of functions together in the same area, standing wheat and wheat that's laid down in spiral patterns, you have different topologies, and perhaps it's enough to create a topological insulator, which is mostly insulating, and then right at the edge, it's conducting. And there's a new state of topological insulators, even called fragile topological insulators. Because you're probably thinking to yourself, well, what's that mean? You're talking about materials that are compounds and they're all put together, and we can understand those becoming conductors, but it's all spread out in the field and so forth. But there's a new state called fragile topological conductors, and this is a very recent discovery, which is that beyond things like crystals and other sorts of compounds that are kind of rigidly formed, you get this same sort of topological insulating effect in other sorts of materials that are not quite as pure. And material scientists are now thinking that you get topological insulators in perhaps 25% of all materials that we know about. 25%. Some even go as far as saying you're going to get these topological insulating properties in almost every material. And so when you get the superconductance, what that means is the electrons are delocalizing. They're starting to act in a quantum manner. In the insulating section, they're just kind of acting in an ordinary way. But when they act as a superconductor, they have what we call they're creating what we call metallicity, and this comes out of other research that suggests that materials that are not even metals can have metal-like characteristics. Isn't that incredible? That if you take crystals and put in a little DNA in a solution, the DNA and the colloidal crystals start acting in a metal-like way. At certain temperatures, the little DNA sections begin to move around like electrons. And at colder temperatures, they act like an insulator and kind of all bunch up. So what we're talking about here are phase transitions, and the crop circle itself represents a type of phase transition. What we're finding is that phase transitions actually can exist in different types of properties that allow those properties to have metal-like characteristics of electron flow, electricity in a very ordinary material. And that is how even a material like wheat could possibly have metal-like characteristics and superconducting effects based on the pattern that's there. Now, if you look over the years, we've had a lot of interesting effects in crop circles, and probably a lot of people don't know about this, but we've seen this in different forms in different crop circles over the years. One example was the Milton Hill Farms formation, so-called. And Colin Andrews and an engineer, Jean-Noel Auburn, went in with a magnetometer and measured the levels of magnetism in this particular crop formation. And what they found was that there was a pattern of magnetism very similar to the shape of this crop circle, but it wasn't exactly the shape, but it was kind of overlaid where the circles were. This was a formation around an old Celtic mound. And the formation was these four circles surrounding this tumuli. And what they found is that the magnetism is very well matched to the actual shape of the crop circle. Now, at the time, they used a very high-quality magnetometer that they actually dragged across the wheat. And at the time, they thought, how could you get this magnetism there? It's very strong. It suggested that it was strong lower, below the surface, and so forth. I mean, were there magnets there? Well, I later found out that this crop circle was indeed man-made. I got to meet all 5 people that were actually involved in making this circle illicitly. And they didn't bury any magnets there. So what is really going on here? You have this, is this kind of an induced magnetic effect that is created from the pattern of the wheat, from the topology of the crop circle structure? It's a really question we have to think about. And other people at times have reported that their compasses start spinning around when they go into a crop circle. So is this also kind of an induced magnetism, what's called synthetic magnetism? The importance of this is we have all of the elements for a very sort of exotic type of quantum object from ordinary materials, namely wheat. And again, this shares a lot of properties with topological insulator, because in classic topological insulators, you have this kind of magnetism from the materials that are already embedded in these compounds. And the magnetism ends up pushing the electrons out to the edge again. So we get this kind of edge effect. And here in these crop circles, we have this sort of magnetism, and you have to wonder whether it's pushing these electrons in a kind of delocalized way out to the edge. Because what I've seen when I've gone into a lot of these crop circles is that if you have your devices, in some cases you have static electricity meters and so forth, right at the edge you get the device completely bonking out. I mean, just failing. It doesn't work. It doesn't work so badly, you have to take the batteries out to reset the device. You just can't turn it on and off. We've seen this in cameras and the static electricity meter. So this is a kind of an edge effect. In any case, what I'm suggesting to you is that these crop circles, regardless of how they're made, whether they're made by ETs or people, it doesn't matter. It's just once they're there, it has these quantum effects in that space itself. And this is very reminiscent of what Hal Puthoff was telling us about metamaterials and recovered materials from these UFO craft that he mentioned in the SSE conference last year, 2018. Because he said that in these compounds, if you beam terahertz radiation into them, it would start affecting the structure of these materials to the extent that it would even change how they interact with space-time. And he calls that space-time metric engineering. So you have to wonder whether crop circles are a type of space-time metric engineering. Perhaps unintentional, but the net effect is they have these sort of properties which are really at the edge of what we know about how materials can work. I mean, I think it would be very interesting if that's how it turned out to be. And I actually can't prove that, but it's certainly one explanation for why our electronic devices act so strangely in these formations. Now, one other interesting aspect here is if these crop formations have properties of topological insulators, then it would also go a long way in explaining some of the other weird effects that people have described around crop circles. This is weird temporal effects, in other words, feeling like time operated in a kind of an unusual way while they were in the crop circle, that it seemed to expand or contract in ways that they couldn't explain, feeling like you were there for much longer, or having interesting temporal anomalies with your watches, things like this. Also, strange objects that are seen in and around crop circles, strange light phenomena, balls of light, even UFO type objects that even the human circle makers have reported seeing over their formations while they're making them. And it would also seem to explain why some people have apparent remote viewing types, precognitive experiences with crop circles in some cases, seeing the shapes in their minds before they appear, or having spontaneous feelings of going out to a particular area and finding a crop circle there. These would all be explained by the types of space-time shifts that you get that would be associated with these types of phenomena. And when I was at the 2018 SSE conference, I got a chance to talk to Hal before and after the lecture, and he did admit to me that these UFO materials that they've been studying, he only talked about one type at the conference, the bismuth magnesium compounds. But he did admit to me that these are topological insulators. And then he wanted to know, why are you interested in topological insulators? So we know that these UFO metamaterials are also topologically insulating materials. And there's one sort of bigger impact of this, is that when you look around you, you sort of think you know what these materials are in your environment, right? There's insulators like wood and plastics and rubber and things like that. And then you have your computers and devices, things like this that conduct. But let's say those things could switch around and the conductors could become insulators, the insulators could be conductors, and very ordinary objects could take on very exotic properties, even to the point of acting like some of these UFO metamaterials. It's a kind of a mind stretch, isn't it? And this is sort of what crop circles did for us over the years and continue to do. And it makes you wonder whether you really understand the world around you, or whether the things that look like very ordinary objects could have very non-ordinary effects that you can't even imagine. But nonetheless, you see from these sort of examples that I'm giving you. So it's just something to think about. Well, that's it for now. But if you have any questions or comments, please feel free to put them in the box below. Like and subscribe. Again, thanks for listening to this, and we'll talk to you next time. Take care for now. Bye.